Hello everyone, this is Ketish here. In this video, I'm going through the AQA 2018 Paper 1 Higher Tier for the Combined Science Physics. Question number 4 is on the atomic structure. The Chernobyl disaster was a nuclear accident that happened in 1986. Radioactive isotopes were released into the environment. The radioactive isotopes emitted alpha, beta, and gamma radiation. Those are the three types of nuclear radiation. So remember the symbols for alpha, beta, and gamma. So alpha, beta, and gamma radiation. What is an alpha particle? Now, alpha particle is a helium nucleus. Remember, if you look in the periodic table, helium is the second element. So it has 2 protons and it has a mass of 4. Right? So tick one box, 2 charged particles, but that would be the protons, and 2 neutral particles, that will be the neutrons, which makes the mass up to 4. So it would be the first option. 2 charged particles and 4 neutrons, that would make the mass 6, which is incorrect. 2 charged particles, 4 charged particles, that would make the proton number to be 4. That will be the 4th element, which is incorrect. And the mass is also higher here. The mass is 8 and the mass is 6. So it's option number 1. 4.2. Which statement about beta radiation is true? Now, beta radiation, right? The description for beta radiation or beta minus is a fast moving electron. It's a fast moving electron. So mass is 0 and the charge is -1. We can write it as B 0 minus 1, or we can also write it as E for electron with a mass of 0 and -1 as well. It is the fastest moving type of radiation, not really. Electromagnetic radiation, which is gamma, is faster with a speed of 300 million meters per second. It is a type of radiation with a negative charge. Yes, that could be. It is a type of radiation with the greatest mass. No, that is an alpha particle. That would be the, no, that is a gamma. Let me change that. Why cannot I change? One sec. So that would be a gamma particle or gamma EM wave. It is the type of radiation with the greatest range in air. That is also gamma. So it's the second option. Next question. 4.3. Which statement about gamma radiation is true? It is a low frequency electromagnetic wave. No, gamma has the highest frequency of all the electromagnetic waves. Radio waves have the lowest frequency and the highest wavelength. Option number 2, it causes the charge of the nucleus to change. It's not ionizing. It's the least ionizing of all these 3. It causes the mass of the nucleus to change. Not really. As usually mainly happens because of alpha radiation. It has a very long range in air. That is correct. So the first these three questions are actually related to the properties of alpha, beta, and gamma. It's a really good opportunity to revise. So if I bring in some additional notes, properties of radiation, alpha, beta, and gamma. The charge of an alpha is +4. The mass is, ooh, that's a mistake there, right? The mass should be 4. Beta is -1, and the mass is 0. Gamma is 0 charge and 0 mass. And other properties of alpha, beta, and gamma would be described in this box. So alpha particles penetration through materials, it's not verified. It's only a couple of centimeters, about less than 2 centimeters. Beta particles probably about 10 centimeters, right? And gamma actually can travel through far. Range, ionizing power, alpha is a strongly ionizing and this is weakly ionizing, and alpha is usually stopped by a piece of paper. For gamma, you need thick sheets of lead or concrete. Beta is usually stopped by a thin sheet of aluminium. Table 3 shows the half-lives of 2 of the radioactive isotopes that contaminated the environment. Cesium-137 with a half-life of 30 years and iodine-131 with a half-life of 8 days. A soil sample was taken from the area around Chernobyl in 1986. The soil sample was contaminated with equal amounts of cesium-137 and iodine-131. Explain how the risk linked to each isotope has changed between 1986 and 2018. Both isotopes emit the same type of radiation. Now, iodine with a short half-life would actually reduce its activity in a much fast time compared with cesium, which has a half-life of 30 years. So let's say, for example, if you start both of them with 100% radiation, after 8 days, iodine, the radioactivity would have dropped to 50%. After 16 days, it drops to 25%. And after another 8 days, which is 24 days, it goes to 12.5% and so on. So within about a couple of months, the level of radiation from iodine-131 would be so little that it doesn't actually have any effect, right? What they're asking is explain how the risk linked to each isotope has changed between 1986 to 2018. Now, if we were to work out the difference, 32 years has passed or elapsed. So bring that to focus. There you go. Right. The risk or the activity associated with iodine has decreased by a large amount to nearly zero because of its short half-life. But the risk or the activity associated with cesium-131 will not have decreased, or it would have, you could say it only decreased by 50% since only one half-life has passed because it has a long half-life. So the risk from cesium is still there. Iodine is not there anymore after 32 years. Question 4.5. Determine the year when the activity of the cesium in the soil sample will be 132, 1/32 of its original value. Right, now, there's different ways of doing it. I'm going to show a simpler method. You're starting off with the full 1, right? After 32 years, you're going to get only half After one half-life, half of the radioactive isotope is going to be there. After another half-life, half of that is 1/4. After another half-life is going to be 1/8. And then 1/16, and then 1/32. So how many half-lives has passed? So let me change the color for that. 1, 2, 3, 4, 5 half-lives has passed. So 5 times 30, which is 1 half-life, is equal to 150 years. So since we started in 1986, we add 50 years to that. That would give me 2136. So the radioactivity level would have dropped to 1/32 of its original value in 2136. 2136. That brings us to the end of this question. I will see you in the next paper. Thank you.